can always use the chat, and then you can always talk. Whatever makes you happy. I'm going to share my screen in a sec. I was just like, y'all can see my face today. I look decent today. So there you go. All right, so we're all good and ready? I hear no one saying they aren't, so let's do it. All right, so hopefully the Khan Academy stuff kind of give y'all a break from just doing notes and also gave you some background here. All right, so what we're going to start with, and y'all can still see the screen, right? I just like opened multiple windows. I'm going to assume that's a yes. All right, so from here, we're going to start with some log rules. All right, so there's a couple of rules, just like with exponent rules, right, that you had rules for. So these are the properties that we're going to use, right? You have your product property, your quotient property, and your power property. And the other thing is this right here, right? This is just the definition of what a log is, right? That's how you go from the log version to the exponent version. Okay? Nice and easy. Okay? And so the thing is, if there's not a base of a log, right? So for instance, in this problem, number 3, there's no base, right? Whereas here, there's a 3 and a 7, right? Then you assume that it's a 10, all right? So that's just an assumption you can always make. And then we did a little bit of a supplement with natural logs, right? And natural logs are ln, right? And ln's different, right? In that it has a base of e, right? And remember e. And do y'all remember what e is equal to, more or less? What's our estimation for e?
2.71, I don't know.
Yeah, 2.71, perfect. All right, so all of these rules apply for natural logs as well, right? Because a natural log is just a log with a base of e, right? Where these have logs, this base is like b, or more b's, or 10, right? Or a over here. Here it's just a log with a base of e, but instead of writing it out, we write ln. And the reason we do that is it's super useful in physics classes and upper level physics and upper level engineering and so on and so forth. Okay? All right, so real quick, we're going to start with this property, right? So we want to know when one of these is equal to 1. So what I'm going to do here is I'm going to say this is equal to x. We're going to put that, or y, right? So just to match this, I'm going to write it as equal to y. And then I'm going to write this in exponent form. So remember when we're converting these in exponent form, we're going to start with the 7, right? And we're going to do 7 to the power, right, of y equals this number over here, which is 7, right? And I'm going to do that. Actually, different colors would be wise, so bear with me, y'all, while I struggle through this, as per usual. All right, so this b is going to be a 7, right? And then it's equal to 7. Okay. All right, so what would y be equal to then? What does y have to be equal to? Sorry?
1.
1, exactly, right? So y is equal to 1 in this case. So we know that y is equal to 1 because 7 to the what power equals 7? Only 1. So this tells us that y is equal to 1, right? Which is the point. So our answer to this is this equivalent to 1? Yeah, right? So the answer would be yes. Okay? So we're going to do the same setup for all of these. So with this one, again, we're going to set it equal to y. All right? This is a little different because I have 2 different numbers here, right? So remember, this is just converting this to exponential form because we know our exponent rules, right? So 3 to the y power equals, oh, did I mess up my colors again? No, I didn't. Okay. Equals 13. All right. So is y going to be equal to 1 in this case?
No.
No. So if y is not equal to 1, then the answer is no. Make sense? This setup should be super easy. Basically, if these two aren't equal to each other, then y can't be equal to 1. Okay? Because we're just doing exponential rules. All right, so on number 3, what do we assume the base is, since there isn't a base that's written there?
10.
10, right? Because just over here, we just talked about that. So this is going to be a 10, right? And then we're going to have 10 to the, we got to put in our y again, y power equals what?
7.
Very good. All right, so it equals 7 from here. There you go. So in this case, is y equal to 1? 10 to the what power equals 7? Is it 1?
No. It's not 1.
Right? Because 10 to the 1 power would equal what? Any ideas? 10 to the what? Oh, sorry, 10 to the first power would equal 10, right? So it doesn't equal 10, so the answer is no. Okay? Sorry, that was not my greatest explanation ever. All right, and then again, what are we assuming the base is here? What do we assume the base is? And remember, you can use the 10 talking. 10, very good. All right. So from here, it's 10. So again, same exact writing it out. So go ahead and do that on your own really quick. At this point, y'all should be good at this. So it's 10 to the y power equals 10. And what's y equal to in this case? 10 to the what power equals 10?
1.
1, right? So y equals 1. So then the answer would be yes. Does that make sense? Kind of, sort of. How do we feel?
Pretty good.
All right. Oh, sorry, Franklin. I totally did not see that you were in there. All right. Good deal. All right. So let's go ahead and do these next ones. So these are a little bit different. Here, what we're going to do is we're going to use our log rules to some extent. So, oh dear. This should be fun. All right. So, all right. So what we found out by doing these problems, right, is that I'm going to write this rule up here. Or this, right? When log AB, right? So if it's log the same number both times, x and x, right? It equals 1, right? That's what we saw here, and that's what we saw here, right? So that's what this rule means, okay? It just means that, okay? So in this case, we know that this follows that rule, right? Like this part right here, it has the same base and the same number here, right? So what is that part equal to? The purple part. Can y'all see that? Exactly. Good. All right, so that's 1, right? And then we just bring down that 3x, right? Because we only dealt with the part in the box. We still have that 3x to deal with. And what's 1 to any power? And
1.
Good. So this is just going to be, oh, okay, actually what we're going to do with this, my bad, is, okay, scratch what I just said, also erase it because I messed up here. Real quick. I'm sorry, I apologize. Just realized what I did. So before we do that step, which I was too excited about, before we do that, we want to deal with the power first, right? Because PEMDAS, we do powers first, powers, exponents, whatever, right? And so for that, we're going to use the power property, right? And so what happens with the power property, I'm going to do that in orange, is this n, right, moves over, right? So if we have a power up here, we can move it down here to multiply it, okay? So here, what's our power?
Three x.
3x, good. All right, so that 3x is going to go over here, and then we're going to rewrite our log, okay? Okay. And now what are we going to do with that log 2? This, what we just did, which is this equals what?
1.
1, exactly, right? Because anything with a 2 and the 2 is 1. So that's 1 and 3x, right? And if you multiplied those, what would you get? What's 1 times anything? Y'all are killing me here. Good. Thank you, Jasmine. Good. So our answer is 3x. Okay? So all we're doing is applying rules. This is something that I want to practice a little bit more. So we're going to do this today, the applying rules, and then I'm going to give y'all some Khan Academy stuff to do tomorrow to really practice this because this is a hard concept. So if you're not getting it right now, that's okay. We're going to keep working through it. And if you are getting it right now, the Khan Academy is going to be super easy. You don't need to watch the videos or anything like that. Just do the exercises. Okay? All right. So for number 6, let's try that. So first we have to deal with our exponent, right? What's our exponent in this case?
X minus 1. X
Yeah,
minus
very
1.
good. X minus 1, right? So where does that go? We're going to move it, right? So just like we moved it over here, we're going to move it down here, right? So, good. Thank you, David. All right, so from here, right, we have our x minus 1, and then we still have our log 10, right, that we just bring down. All right, now let's deal with this log 10. So what's our invisible base here? 10, very good. All right, so here's our invisible base right here. So this is going to give us what? 10 to the what power is 10 is what it's asking us, right? 1, exactly. Very nice, Jasmine. All right, so we have a 1, and then we have an x minus 1. We're going to multiply those, so what's our final answer? X minus 1. Very good. Right, because 1 times anything is just itself, and these were just being multiplied, right? Does that make sense? How do we feel? Need like a gauge here. Can I like give y'all a poll on how you feel? I should try that. I'll try that later. Anyway, okay. So for number 7, right, we're going to do the same exact thing that we just did in number 6. So I want y'all to try that, okay? So try that with number 7. All right, and once you get it, go ahead and actually, let's go in the chat and write down your answer, okay? Don't say it out loud so people can try it themselves. Very nice, very nice. All right, so what are we going to do first? We're going to do the power property, right? Which is moving the x, right? So power property here. Remember, we do need to know the names of those just in case you have one of those questions where it asks you to explain what happened or what was wrong, right? One of those error questions. So this is the power property of the orange, all right? And then after that, we assume that our base is 10, right? The invisible base. And so then we know that this whole thing is 1. So 1 times x, right, gives us an answer of x. Very nice, y'all. All right, go ahead and try the last one. The last one is just like number 5. Y'all are doing really good, actually. I'm impressed. All right, very nice, very nice. So I'm just going to go ahead and write out my work here. But again, we're going to do this, right? That's called the power property. Just write that down somewhere so you remember. All right, it's really, really important that you remember the names of these properties, okay? All right, because I know that's what y'all missed a lot when we did the exponent rules, when I graded those tests. Some of y'all forgot the names of things, and you lost points, and that's never fun, all right? All right, so then log 5 base 5, and we know that that equals 1, right? And that would be called the identity property, right? So from here, we know that that's 1, and then we have 7x, right? And then when we multiply those, you just get 7x. Very nice, y'all, very nice. I'm glad that we are getting this. Okay. All right, so from here, let's go ahead and move down to this one. All right. Okay, so this we're going to use different properties, right? So real quick, if you look up at these properties, which I can't show you both at the same time, so hopefully you have them written down. Right here we have this product property, right? Where if you add them, and it's really important here, right, that they are the same base, right? So see this base and this base, those have to be the same in order for this to work. But if you're adding two separate logs, you can merge them, but you end up multiplying them, okay? That's the product property. I'm going to do that one in green. And then you have the, I need blue, there we go. The quotient property, and that's just the opposite, it's subtraction, right? So again, we have the same bases here, right? And when you subtract, instead of multiplying like you do with adding, you're going to divide, right? Which is pretty logical, all right? And I'll do that in blue. Okay, so from here, we have the set, right? Number 9. So what we're going to do first is we're going to say, okay, do these have the same bases? Yes, they do, right? And are we going to use the product property or the quotient property? So y'all tell me. Product or quotient?
Product.
Product, right? Because we're adding, right? So we're going to use the product property. And that's similar to if you think about exponents, right? Exponents, it's the opposite, right? If you're multiplying them, you add the exponents. Here, when we're adding them, we multiply. So remember that logs and exponents are the opposites of each other, but they do have a lot of those patterns, okay? So from here, right, these are the same, right? So we know that we're going to use the product property, but before we do that, we have to deal with the squared, right? Because when we look at the product property, it has nothing over here, right? So we need to move that squared over. How are we going to do that? What do we do with those exponents? How can we move them around? Any ideas on what property we might use to move an exponent? The power property. Very good, David. All right. So the thing is with the power property here, we can do the reverse of what we did up here. So right here, right, we move this 3x. Sorry if y'all can't see that. We move the 3x down here, right? On this side, what we're going to do is we're going to do the opposite. We're going to move the 2 up here. The power property just says that we can switch between these two. So whatever is convenient, we can do. All right? So what I'm going to rewrite this as log 7, 3, and log 7, 5. And then that 2, we're just going to put up here. So it becomes 3 squared, right? All right. And so if it's easier for y'all to see this, what we're doing here is we're actually taking the log of that whole thing, okay? And then over here, the parentheses would just be here, right? Because there's nothing squared, okay? All right, so we did the power property, right? And I would highly suggest writing this down a couple times with your notes just so you know what you do. Okay, so there's the power property. And now we're going to use that product property, okay? So now that we've added, right, product property, I'm doing in green, right? We have the same bases, so we can go ahead and add these. And when we do that, by the product property, we're going to end up multiplying them, right? All right. And if we were going to do that with a number, what's 3 squared? Come on, y'all. 3 squared.
9.
Good. And then 9 times 5 is?
45.
45. Good. All right. So there we have it right here. Does that make sense? And that would be our final answer. So that's it. So basically, we are trying to make them into the smallest answer possible. Think of it as simplifying, right? We're using our log rules to simplify. And of course, this is called the product property. I should have written that. Okay. So I want y'all, because the struggle is good for you, productive struggle or whatever, I want y'all to try number 10, okay? Let's go ahead and take a moment to do that. It's very similar to what we just did. The only difference is the power property is over here right now, okay? So I'm going to freeze my screen so I can do the problem. And once y'all get it, go ahead and type your answer into the chat, okay? I'm slightly worried that I'm not seeing answers. Are we just super confused? Because it's okay if we are. I just need y'all to tell me. Oh, okay. Maybe we are. Okay. David, real quick, check your math there, okay? Yeah, there we go. Yeah, it's good, 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 good. All right. Okay. Okay, you all getting it. That's good, that's good. I just need to be patient. All right, so right here, we just followed the same things. We started with the power property, right? And then once we were able to, we were going to do the product property. So we just added them, right? Sorry, multiplied them from our addition to multiplication. And then we just have to remember to 3 to the 4th. You can either use a calculator if you want to, or you know that 3 squared is 9, and you get 2 9s. 9 times 9 is 81. Then 81 times 5 gets you 405. There you go. Super easy, right? Hopefully. I don't know. How do we feel? I feel like it's kind of just a lot of things to remember, but it's not hard per se. Okay, good, good, good. All right. So let's try these next ones. The only difference here is what? What's different about them? For number 11 and 12. Right, we're going to end up dividing because we have a subtraction, right? So we're going to use the quotient property. But first, let's start out. What do we have to do before we even get to the quotient property? What power, or sorry, oops, there you go. What rule? Power rule, exactly. All right, so we're going to have to move this 2 over here, right? So power property. All right, and once we do the power property, we're going to rewrite. So we get log base 3, 6 blah, minus log base 3 of 9. Good, and it's 6 to the 2nd power. Good. And then from here, right, we would rewrite that with the quotient property this time, right? And remember, the quotient property just means we take subtraction and we turn it into division, right? So when we subtract these, instead what we can do is we can merge the log base 3, right? We only have one of those left. And then what changes here is it's 6 squared over 9. Okay? Does that make sense? All right, and then what's 6 squared? Anyone? Good, good, good. All right, so then we just simplify, right? 6 squared is? Good. And then 36 divided by 9 is? 4. Exactly. Right, so that would be our final answer right here. And I know I changed the color scheme just a bit, but I think that's easier to understand and follow. Yes, Franklin. All right, good, good, good. All right, so y'all try number 12 real quick, okay? And I will try my best to be patient here. I'm not a patient person, but we'll see. We'll see. I can do it. Good. I'm going to give y'all just a little bit to finish up, but y'all are on the right track. Sorry, I feel hard. My dad just dropped something. Good, so how are we doing? I think everyone's starting to get it, but I'm going to give y'all a couple seconds while I finish writing to finish up. There you go. That's that 8 over 10, 16 over 10, which simplifies to, I guess I'll write it out. 16 over 10, which equals log 8 of 8 over 5, right? All right, and you could either leave that as 1.6 or you could do 8 over 5. I don't care which one you do. If it was on a test, a question like this would probably be multiple choice anyway, so not a big deal, all right? As long as you can convert between the two. All right, so from here, right, one other thing I wanted to mention really quick, so this is definitely your answer, all right? But I just wanted to mention that another way to write this is also the same thing as writing it like this, right? Those parentheses are really only useful when you have powers or multiple numbers going on, but you don't really need the parentheses when there's just one number. Those are the same thing, okay? Okay, it's just to hold things together when there are multiple things or there's a negative, you know, the usual. All right, so how do we feel about that? So far, so good? All right, because if so, we only have a little bit left. This stuff is pretty easy, all right? All right, so for number, let's see, y'all can see this, right? Hopefully, good. All right, so for number 13, right, this is the kind of multiple choice problem you would probably see, okay? And we start out with here, so which is equivalent to this, right? So let's just go ahead and solve this, right? We're going to start with our usual properties, right, which I'm going to actually put up right here, right? So our properties are going to be, for this one, right, we're going to use either this property or any of these properties, right? So these are all our properties. What property would we go for this? What could we rewrite perhaps in here? Okay, so not quite. We could use the product property. I lied. Yes, you can. How would you do it, Alex? No, you were right about product. Go back to product. How would we do it? For instance, okay, so I feel like we're a little bit confused on how to go about this. So there's a couple ways. You can either just look at this problem and know exactly what to do. Okay, Alex. All right, so you can either look at this problem and because I've practiced with these a lot, I know exactly what to do. Or you can actually look at each individual problem, right? So let's just do process of elimination. I can't talk today. All right, so for A, for instance, this has a base of what? What's the invisible base for a natural log? E. Very good, Sophia. All right. So this is an E. Is there an E in this problem at all? No, right? Good. So that means that this is just not going to be an answer, right? This doesn't make sense as an answer, so we're going to cross it out. All right? Let's go ahead and go to this next one, right? Let's try that power rule out. So when we take the power rule, we're going to take this 2 and move it over here, right? And so we'd be left with, there we go, log base 3, and then the 8, right? And then our 2 would go up here, right? And what's 8 squared equal to? Oh, 8 squared, y'all. Right, so this would be equal to log base 3 of 8 squared, which is 64, right? 8 times 8 is 64. That makes sense what I just did? And so when we look at this log base 3 of 64, right, these have the same base, but other than that, they have completely different numbers. So this couldn't be an answer either, okay? So what we're trying to do here is we're just trying to put it in a form where we can compare them, all right? That's our goal. So go ahead and try that for the next couple. I want to see what y'all get as your answer, okay? I'm going to give y'all a poll so you can answer. I think. I'm going to try it. We'll see how it goes. Answer number 13. A, B, C, D. All right, so go ahead and do it in the little poll thing. I think I did it. I don't know if I did it. Hopefully I did. So you should be able to see the poll in the chat. Go ahead and use that, please. That way I don't think you all can't see who's answering what. I can only see it, okay? And I can also see where everyone's at, okay? Like, did y'all use like eye clickers back in the day? It's like that. I don't know, y'all might be too young to use eye clickers. It's a glorious time in my life. All right. All right, it looks like we're on the right track. I'm gonna let a couple people finish up and answer before we move on. What's 2 to the 5th power? 2 is 4. I don't even know. Not 16. Right. All right. So, all right, good. We have 9 people. I'm pretty happy with that. All right, good. So, right, for D right here, I'm going to go ahead and do this problem, right? So if we did, what property would we use? Product property, right? If we were here, we'd rewrite this as log 3, and then 8 times 2, and we know 8 times 2 is 16, right? And that matches this, right? So that would be our answer. Make sense? I feel like y'all are doing pretty well with this. All right, let's go ahead and try number 13. So I'm going to give you another poll, and I want y'all to go ahead and do this, and I'm going to also work through it as well. But I want y'all, if you would like to work on your own. Did I totally answer this? I wrote number 13 on the last one, didn't I? Great. Oops. Oh well.
For number
Yeah.
for number 12 for E, would you like? How would you this?
Here, give me just like half a second, actually, because I can't multitask. Y'all know this. I'm terrible at it. Okay, there we go. Let me just submit this. Send. Okay, good. So for E, right? What I would do is that's quotient row, right? So you have a quotient, and with a quotient property, you can go backwards, right? And so basically what it's saying is if you wanted to go backwards, you could rewrite this as it's equal to log, what would it be? 3 minus log 17, right? And you'd realize that this doesn't make any sense. Like this doesn't connect with this in any way, right? So that's why it wouldn't be an answer. And we'll see. So that question is in there, or that option's in there because in Unit C, we start talking about change of base formula. And there is a formula that's similar to this that we'll use, but we're not there yet, so don't worry about it too much. Okay? All right. So, y'all should be working on actually 13. And as y'all work through that, let me know what you get, okay? And so here you might need to do process of elimination, okay? In fact, you probably are because you don't know the change of base formula yet. So this one, so be very careful with this one, okay? This is a question that I wouldn't give you on a quiz until we'd done 10C, but it is good to just make sure you're doing process of elimination, okay? All right. So for instance, for this first one, right, we'd start with a nice little move the power over, right? So we'd end up with log 7, 5 to the squared minus log 7, 2, right? And then after we move the power over, we could switch that into, say, product, or because it's subtracting, it'd be quotient property, right? And so we'd be left with log 7 of 5 squared is 25 divided by 2, right? And that's obviously not the answer because 25 divided by 2 doesn't equal 10. So cross it off, all right? And then if we tried C, right, no need to do product or power rule. We could go straight to this, right? So we could write log base 7 of 12 divided by 2, which is log base 7 of 6, right? That's also not equal to this, so it wouldn't be C. All right. And then if we went to D, right, here we're going to do product rule, right, because we're adding here. So it'd be log base 7 of 5 times 5, which is log base 7 of 25. Also not helpful. You can see how they tried to trick you with 5 plus 5 instead of 5 times 5. Okay. So now we know it's one of those two equations that we don't quite know the answer to, all right? Because we haven't seen these, right? Because these are called change of base formulas. Again, you wouldn't have a question like this on anything I would grade until we'd gone over it. But I did not make these notes, and I did not realize that that was on there, or I would have caught that, okay? So what you can do here, and what I would advise you to do actually, is to use a calculator, right? So you can plug this into a calculator. Let me see if I can show y'all how I would do that. Let's see. So anything right with numbers, you can always plug into a calculator. So if I was using, for instance, let's see. Oh, you know why? Because I'm not on Google. I'm going to share y'all my screen in a second. Let me just get this set up. All right. So if I had, how do I share? Stop sharing this screen. Okay. And then I'm going to share this screen. Okay. So hopefully this is what y'all see, right? So we have log 10, right, divided by log 7, right? And if I did that here, what I get is 1.18, right? And to see if it's equal, of course, right, so I would write 1.18 down on my sheet of paper for A, right? And then if I were going to see if it's equal, shoot, y'all can't do this on this calculator. For the minute, I think what's going to be best is we're just going to tell you that the answer is A, all right? Because I don't quite know how she wanted you to do this problem. And so we're just going to go with that, all right? Yeah, she was very unclear. I guess the other way to do this problem, if you really wanted to, is to just look at estimations, right? And again, don't worry too much if you don't catch this. But real quick, you could say that this, like, log 10 to the base 10 would be 1, right? So I know this is 1 divided by 10 to the 7, which is going to be smaller, right? Like 0.8 maybe. So that'll be greater than 1, whereas 7 to a power has to be greater than 1 to get to 10, so it should be A, whereas this would be smaller than 1. But honestly, it's a lot of details, and I wouldn't worry about it. You wouldn't get this question until you understood better. Okay, cool. Let's just move on. That was like an unnecessary question. Don't worry about A versus E right now. Okay? Sorry, y'all. I did not realize she had thrown that in there. Nice little surprise for me. Oh, there we go. Okay. So if the base of a log is not written, we already know it's what? We talked about this before, so y'all can go ahead and write it. This will be a 10. Good. right? So it's going to be 10, just like we talked about before. Very nice, y'all. All right. All right, so here, I'm not quite sure why we decided to re-talk about it. Except that this here is going to be your natural log, right? So anything like this would be equal to natural log of y, okay? So just write that down right there, okay? All right, so natural log of y is equal to the log base e, right, of y, which is equal to x. And you could rewrite it in exponential form like that, okay? All right, cool. All right, so let's go ahead and do this problem, right? So remember, we're just switching from logarithm form to exponential form. So it starts in log form, right? And what we're going to do is the same thing that we did at the beginning of today, which is take the base, which in this case is 3, right? And we're going to do 3 to the what power. So the what power is like the answer. That's the 0 right here, right? So we're going to take 3 to the 0 power equals, and that's what equals this part. So what's in the parentheses is what we put here. All right? So it's just converting, again, from exponential to, or logarithmic to exponential, which y'all should have practiced a lot with the Khan Academy. All right? And then from here, we just need to practice. So we just need to solve this. And we know how to solve this. What's anything to the 0 power? Why is it like this? 1. Very good. All right. So anything to the 0 power is 1. All right. So we get 1 equals 2x squared minus 17, right? And then how would we solve this? Super straightforward. How would we solve this? Just solving an equation, getting x by itself, right? So that means we're going to add. Good. All right, so add 17 to both sides. So we're left with 18 equals 2x squared, right? And then divide by 2. So we get 9 equals x squared. And then how do we get rid of a square? What is the opposite of a square? Maybe is a better question. Square root. Very good. All right, so we square both sides. And so we get x equals what? Not just 3, though. Be really careful here. Not just 3, but plus or minus 3, right? Good. All right, so that would be our answer, okay? And we don't have to check for extraneous solutions unless it tells you. So you don't have to plug these in. We're done, okay? Because it didn't say anything about checking. It'll tell you if it wants you to, okay? All right, let's try number 15. Same general process, right? So I'm going to color code the same way. We're going to take our base, right, which is 4, right? That is called a base, just in case y'all are confused by what I'm saying. That's a base, right? So 4, and then we're going to take the answer, right, over here, and make that our power, right? And we're going to take the stuff that's actually being done with the log, and we're going to put it in here. And then from there, it's super straightforward, just equation solving stuff, right? So we know 4 squared is equal to 16, right? Oh, there we go. Equals 3x squared minus 59, right? And then we would just solve. So add 59 to both sides. Super basic. Hopefully y'all have this part down. Right. Oh, that's wrong, isn't it? Oh. That's not how math works. Is it 75? There we go. Right, so just solving, nice and straightforward. Right, the only hard part here is just remembering that we have to convert first, right? The rest of it's very easy, very review-like, right? And then for here, we square root, and we get x equals plus or minus 5. All right. Hopefully we feel good about that. I want y'all to try the next two, and then share your answers, okay? So try the next two, number 16 and 17. Hopefully these are pretty easy. And then even share your answers, all right? I'm not going to leave these up so you can see them. Oh, y'all are so ahead of me. Okay. All right, so go ahead and share answers. I'm going to just make sure everyone is in the same page. Y'all are really good at this. This makes me happy. All right, so hopefully this is probably the hardest part right here, and you were able to solve from here, right? All right, and so we're all agreeing that it's x equals 9, right? And x equals 6, right? And I'll go ahead and do the work when I post the notes, the inked notes, if anyone's having trouble with that. But it seems like y'all are pretty good with that, and it's just algebra from there. All right, so that's all I have for today. The practice is, of course, available. And then I'm going to go ahead and assign y'all some Khan Academy. And then we'll do a quiz. I'm not quite sure how I'm going to do the credit yet. I will let y'all know as soon as I figure it out. My hope is to make it actual quiz credit. But in order to do that, I'm going to have to use Land School and make sure I can control your computers and, you know, all of that nonsense. So we'll see how that goes. No promises. But if I can make it quiz credit, I'm going to. Just so that y'all have some actual things in the gradebook, okay? Do y'all have any questions for me? Any questions at all? Questions about life, questions about math, questions about, I don't know. That's kind of all I got. Like, I can't answer any other questions. Life and math more or less covers everything anyway.
I got a question.
Okay, what's that?
How do you know you're not cheating on the quiz?
That would be why I would use Land School and also control your webcam to make sure I can see you. Which is nice and creepy, I know. But I'm worried that this, like, if this goes on for too long and all you have is formative assessments in the gradebook, that would kind of suck. So I want to make sure you're getting quiz grades and then hopefully assessment grades at some point. Okay? Cool. Anyone else? I mean, I don't know, David. So hopefully, like, the question was what would happen if we don't come back? Hopefully nothing. Well, hopefully we do come back, right? Because I don't really know what they would do with common assessments. They're allowing me to do grading with IAs and FAs pretty much as I want to. But I couldn't give you a common assessment like this. So I'm not really sure what would happen. But I'm working on figuring out a way for y'all to retake your test or reassess or whatever y'all call it. And beyond that, I don't know. I don't know, Vera. Honestly, they would have to tell you because I can tell you what I would personally do, but it doesn't matter. The district doesn't ask me what I want. The rules would probably come from the Illinois government. So you just kind of have to wait. Okay? So who knows about finals or if we don't come back, but hopefully things kind of chill out and we're back in April at some point. Okay? And if we don't come back, we will figure out something. Your grades are going to be okay. Like, don't freak out about that at all. We will make sure that you have the opportunity to reassess anything that you thought you could reassess before all this craziness happened. and make sure you at least kind of learn the content so you're ready for next year. Okay? All right. I think that's all I've got if you don't have any more questions. Again, you can always chat me if you have any questions. Between 9 to 3, I'm pretty available when I'm not teaching honors kids, so I'm happy to help you. Happy to video chat you if you need help with that, or just answer some questions via text. Okay? All right. I'm going to continue putting in grades, so you should see your grade books updating. All right? All right. I will talk to y'all later then. No more questions? Okay. Bye, y'all. Well, I have to stop recording first, but.